Hello, welcome. We have a question on main section 2 on the aspect of the volume of a cone, and a recasting of a particular shape into a cone. So I believe you can be able to provide answer to this if you've watched the previous episode. The area of a sector of a circle with a diameter of 12 centimeters is 66 centimeters square. So if the sector is now folded to form a cone, we have to calculate the radius of the base of that cone. So we need to find the radius of the cone. Now, we know that the sector, when removed to form a cone, the slant height of the new cone, let's make a mental picture. If this is the sector and if removed to form this cone, this will be removed. We have your height, we have your radius. This is the radius, which we don't know, so let's use r. Slant height is the same as the radius here. The angle subtended by the arc is not given. So if you have this is your height, this is the radius we are asked to find. So now, to find this radius, we need this particular radius. We also need the angle subtended, which is not given in the question. But the whole area that is having the angle is given to us. So we are going to have that connection to say, let's begin with the diameter is given as 12 centimeter. So if the diameter is given, we are aware that a radius equals to diameter over 2, meaning our radius will be 12 centimeter divided by 2. That gives us what? The 6 centimeter. So here the r is known, which is the capital R, which is the slant height here as the r is also known. All right. So what next? We know area of a sector is given by theta out of 360 times pi r squared. The r here is the r of the sector. Theta is unknown. Radius is known because it's going to be, let's use the capital so that we will not get confused. This capital R is the radius of this big sector. The small r here is of the cone. So since we know the r, the pi is known, theta is not known, but the sector area is known. We can find the theta. It's a matter of what? Change of subject. Meaning this gives us 66 equals to theta out of 360, 22 out of 7 times 6 times what? 6, which is the r squared, radius squared. 6 times 6, that will be 36, which can cancel this to give us 10, right? So we'll be having 10 here. Let's take it this way. 66 equals to, if 10 is left here, then in that 10, 5 can go there, 2 can go there 5 times, 2 can go there 11 times. So 11 theta out of 5 times this will be 35. You can do your own cancellation if you are not conversant with the mental cancellation. So here we cross multiply to have 35 multiplying 66 equals to 11 theta. So here we divide by 11 by 11. This will cancel. 11 here 1, 11 here what? 6. I guess, right? Good. So our theta will be equals to 6 times 30. That will be 180. 180 times 6 times 5, 30. So we have 210 degrees. That simply means that the angle subtended here is going to be theta of what? 210 degrees. So if in case we want to find the radius without the use of the height, we know that the length of this arc is the same as the circumference of the base. The length of the arc AB will be equal to the circumference. So if we can develop that. We can say that if the length here is going to be, okay, let's say length of arc equals to the circumference of the base. So we can say circumference of the base. So in this case, the length of the arc is given by theta out of 360 times 2 pi r equals to 2 pi r. Let's take it again. The length of an arc is theta over 360 times the circumference of the circle. So the circle is having a radius of capital R. That will be the same as the area surrounding the base, which is the circumference of a circle, 2 pi r. We can see 2 pi are common. So we can cancel to have our r equals to theta out of 360 times a capital R. So we can do our substitution, which will mean that the angle is 210 divided by 360 times the radius, which we know as what? 6. So in this, our cancellation, we can see that this 0 will cancel this. Then we left with 21 over 36. 6 will also go here 6 times. So 21 over 6 will become 7 over 2. And that will be 3.5, I guess. So our radius will be 3.5 centimeter if we are to follow through. We are only interested in the radius. But all these are paving way for us to get the result. Now, if in case you want to find the radius from here, it means first of all you need to find the height, which is not known. So the only possible way we can do that is using this aspect. You can also use the area of the sector equals to the total surface area of this. You come back to the same 3.5. Thanks for watching. Like, share, and comment. Bye-bye.